Yes. Isotopes. Isotopes. Isotopes means same atomic number but different mass numbers. Isotopes are nothing but same atomic number but different in mass numbers. Okay, so what do you mean by mass numbers? So like now we'll understand. What do you mean by mass?
Ma'am?
Yes.
Ma'am, how are isotopes formed?
Our isotopes formed by the variation of neutrons, neutron number. By the variation in the neutron number of the same element.
Ma'am, I didn't understand what isotope.
Yes.
Yes, I'll explain. I'll show you the video also. I know that all these are imaginary things, you need to imagine it. That's why I'll show you the video after explaining this. Yes, children? Yes? Okay. Isotopes means, for example, hydrogen we are having. Difference in the energy levels, difference in the number of neutrons. There will be a fluctuation of number of neutrons in the same element. Not all elements are having isotopes. Few elements will undergo the change in the number of neutrons. Okay, change in the number of neutrons. So those isotopes, like hydrogen is having 3 isotopes. Hydrogen 1, hydrogen 2, hydrogen 3. This is atomic number. Down one.
How are they formed?
By their own chain. This is not by giving any external energy. By their own.
Ma'am, but
Because
ma'am,
element,
are there like conditions?
not even any other conditions. By their own, there will be a fluctuation. For example, how they found, this is your doubt, am I right? How they found, ma'am? Is that the element is having isotope, how it was found, am I right? Yes?
Isotope.
Okay, isotope in the sense, like 118 elements are there. 118 elements are there. These 118 elements are having same, for example, individual elements are having same atomic number. Number of protons, electrons, and neutrons are common almost. But few elements, there will be fluctuation. Like for example, if within 1 second, I'll observe that hydrogen is having 0 neutrons. And again, if I want to observe, I'll do the experiment. The scientist has found that the neutron 1 is present. And again, after doing the experiment with the conditions like when the experiment is doing not even a different condition, with the same condition, if there is a fluctuation in the number of neutrons are observed. Understood? So this number will be changed. Atomic number is same. Atomic number is same. But number of neutrons will be changed. I think it's not clear for you.
Then the number of neutrons are limited.
Ma'am, can you explain a bit more?
Yes, I'll explain. Let us see this video. Again, I'll explain. I animated one, so definitely I'll explain. Understood? Isotope is nothing but the number of protons and electrons are same for the element. Like few elements, not all the elements can undergo isotopes. Few elements, but there will be change in the number of neutrons. Understood?
Ma'am, means what are isotopes? They are number of neutrons, or the whole atom is called isotope.
Whole atom, I say. Isotopes are nothing but forms of same element. Simply we can say that isotopes are nothing but forms of same element. Like carbon will be in the form of 4 types of isotopes. Understood? Same atomic number but different in mass number. What do you mean by mass number? Again, I'll explain it. No need to get confused. Isotopes are the forms of element. Hydrogen is having 3 forms. Carbon is having more than 5 forms. Understood, children? Arya,
Ma'am,
Ronak,
Yes,
ma'am, how to know that there are more than 4 or 3 or 2 isotopes?
all these are experimental proofs. They have done experimental with the instrument in the laboratory. Then only they identified it.
Yes.
Understood? Without any proof, they have not given these isotopes. Isotopes means carbon. Simply, what is the carbon to represent? For example, carbon is there. Carbon, what is the atomic number of carbon? 6. What is the atomic number of carbon? 6. We need to write it down. Here we need to write mass number at the top. This will be common for all the isotopes of the same element. But here the number changes. In general, this is the original form of the carbon. This is the original form of the carbon element. Okay. So when we consider the carbon forms C613, C614, C615 like that up to 17. Now the one more new one was found, it says. Okay, these are the different kinds forms of carbon. These are isotopes of carbon. Understood or not? These are isotopes of carbon. So when we compare, all are having same properties. They all are same with properties. But when we see the energy, all these are having higher energy. All these are having higher energy when we compare with carbon. And each isotope is acting like radioactive element. Isotopes are acting like radioactive elements. They are used to identify the research works. Any doubts? Any doubts?
What is the 12, 13, 14, and 15?
All these are mass numbers. All these are the mass numbers. So let me explain the mass number, then you will be having an idea.
yes, ma'am.
All these are the subatomic particles. I'm considering what carbon, symbol C. So it consists of 6 protons, 6 neutrons, 6 electrons. Okay, I'll write the element in the full representation of the element like 6. So what is the mass number at the top? Mass number is nothing but number of proton plus number of neutron. Understood? So proton is 6, neutron is 6, combined to form 12. Understood?
Yes, ma'am.
This is mass number. Isotopes means element. Isotopes are the forms of element. That means elements having isotopes having same atomic number but different in mass number. That is nothing but isotopes. Now, did all the elements will undergo having same having different forms of isotopes? No, only few elements. Only few elements having isotopes. Very few, like we can count with our finger easily. So they are not all the elements will undergo isotopes. Only few elements with the different forms are present. They are nothing but isotopes. Isotopes are nothing but element having same atomic number but different mass number. So if the number of neutron is 7, then C6 13. Understood? If neutron number is 8, there won't be any change in proton and electron. Only neutron will change. So C6 14. 6 plus 8 14. Any doubts, children?
Ma'am, ma'am, here proton, neutron, electron all are same of carbon 6 and 6 and 6. Ma'am, then how can it be? How can the isotopes of carbon be there? They are all same.
Where? Here proton and neutron are stable. They won't change. Only number of neutrons will be changed. Then only isotopes are formed. That's what I'm saying. Scientists has found in only few elements they will undergo in different forms.
Why, ma'am? What those few elements have in common?
Like carbon, hydrogen, chlorine, few more elements are there. I'll give you that chart also so that you'll be having an idea. Now we understood now what is the arrangement of 1H1, 1H2, 1H3 means here 1, 2, 3, the increasing number is nothing but mass number. Okay, how the mass number is formed? By the addition of proton and neutron, not electron. Here this one is neutron. The slide you can see over here, number of electrons I have given. This is neutron, not electron. Okay. Any doubts, Aisha? No, isotopes won't have any ions now. Isotopes won't have any ions because isotopes itself having higher energy when we compare with its own element. No, there is no chance of having isotopes having ions because it is the isotopes are equal to radioactive elements. What you did not understand on that about the isotopes?
Ma'am, every element can have then isotopes. What is different between them?
Ma'am, what are the conditions for an element to have?
What we are learning now is proved experimental theories we are learning now.
Question. Under what conditions would an element form an isotope, ma'am? Because you're saying all elements do not have isotopes. So, ma'am,
Yes.
under what condition will an element have an isotope, ma'am?
It's based upon the element chain, the ability of an element to give the isotopes. It is not based upon the conditions, external conditions. It is not an external energy to give or to obtain the isotopes. It's naturally obtained by its own elements. It is 100% based upon the capability of the element. Capability of the element. For example, let me give you a clear cut this thing. If two children are there in the same home, like your cousins or siblings, like that, if two are there, so one is very active, one can manage all the multitask things like drawing, painting, games, sports, everything he can manage along with the studies. Okay, so parents are providing all the conditions to both, equal conditions to both. But one is very much active in all the activities, co-curricular activities, and even he can manage with the studies also. Understood, children? But the other one, though he provided with all the conditions, conditions in the sense all the things, what are the required things he wants, but he can restrict it to only studies or only to the sports. Completely what it is based upon the providing conditions or it is based upon the chain. Ronak?
Chain.
It is based upon the chain. Yes, here also elements, when it is undergoing isotopes in the sense, it is completely based upon the element. The element is showing different forms. Why the other elements are not showing in the sense, they will be having its own unique property. So the elements which are showing isotopes, they are having its property to show the isotopes. So if you are not clarified with the isotopes, let me go with brief in the next coming session. Only with the isotopes. Ronak? And what about the remaining children? Like how many elements have isotopes in the sense? Like only few elements, not all the elements. Only few elements will undergo the isotopes. Like uranium, some radioactive elements are also there. Uranium will undergo isotopes, like sodium also will undergo, like 2 isotopes only. 2. Carbon only is having more number of isotopes when we compare. Hydrogen with the 3. Okay. So when we go with the isobars and all, we'll be having the number of isotopes, how many there. I'll give you the chart and put it. Okay, you want the notes so that I'll share it afterwards. Yes, I'll give you the list. Yes, Naisha, I'll give. Okay. Everything else? Have you understood what is atomic number?
Ma'am,
Okay. Product.
ma'am, the isotopes are chemically proved, so they can't be changed.
No. isotopes, there are like with higher energies, they won't undergo the chemical reactions. Isotopes won't undergo the chemical reactions. The original element will undergo the chemical reactions. Crystals. Okay, very good, Kavya. So isotopes, or like these forms won't go into chemical reaction, children. They'll be having their properties like carbon 13 is there. So carbon 14 is there. C6 14. Carbon 14 is used to check the carbon dating in the sense in the element in the plants, the age of the plants. Because it acts like radioactive elements. Actually, the cost of radioactive elements is very costly and they are very dangerous. Not even yes, in fossils. Yes, Naisha, in fossils we can check by using C14 or in the forensic reports we can check that the age of the person. Okay, the age of the plant. In forensic reports we can check. They won't undergo the chemical reaction because it is having higher energy. Chemical reactant should be stable to react. When it is having higher energy, how can it react with the reactant? It won't react. Okay. So each isotope is having its unique. Some isotopes are used.
Ma'am, I was in the washroom, ma'am. You called me?
Yes, that means whether you're having doubt or not to clarify. Ask you.
Ma'am, can you explain it one more time, ma'am?
Yes, definitely, Chair. Definitely. In the coming session, only with isotopes will go. I'll give the clear-cut chart and the flow chart and how many elements.
What about my doubt, ma'am, about like under what conditions does isotope form?
This I have already explained.
Yes, ma'am.
Did
I
I?
was in the washroom. Sorry, ma'am.
Yes, again I'll explain the next session. Pranay, I explained it now?
Yes, ma'am.
Yes, I explained it. And that's why I have asked you whether you're having doubt or you understand about it.
Ma'am, can isotopes have ions?
Yes, dear?
Ma'am, can isotopes have ions?
No. Isotopes won't have any ions.
Okay, ma'am.
Because it's having its higher energy. That's what I'm saying. To catch the isotope only in some conditions we need to catch it.
Yes, ma'am.
It acts like radioactive elements. It can like a supplement of radioactive elements, simply we can say.